Hello, everybody. Good morning to all our American friends and good afternoon to Europeans. Today, we are here to talk about the future of cybersecurity. We want to discuss what are the plans in ntop, what we have implemented so far, and what we are planning to complete by the end of this year and beginning of next year. Let's now start. This meeting is divided in two parts. On the first part, I will talk about the present, so namely about the current ongoing activities and about the features that are already available in the current version of our tools. In the second part, I will talk about future plans and the developments that will appear in the next release. Let's start with the first part. The motivation is basically very simple. In essence, in 20 years, so since basically the beginning of the ntop project, of the original project, we have seen an increase in speed in the networks. We move from 1 gigabit to 10 gigabit and now to 100 gigabit. We see people that are talking about 200 or 400 gigabit. But we didn't see anything really new in this area. In essence, if we use commercial products such as, for instance, those that are produced by companies that manufacture routers, they are still using the same protocols we used in the past, such as NetCo and SCO. And we have also seen an increase of sorry, somebody has the microphone on. Please turn off your microphone. And so we see an increase of complexity because there is much more traffic. And at the same time, we see that the protocols are still the same. But people want to see more than what they have seen in the past, simply because the traffic is becoming more complicated. And they would like to understand also the nature of the traffic. But unfortunately, the main metrics are still bytes and packets. And this is somehow a problem for many people because the visibility is limited. Another interesting solution that appeared and is becoming predominant in this world is machine learning. And machine learning, it is interesting because it allows to understand the nature of applications and nature of the traffic in a simple way. Because machine learning is very powerful to see things that humans have a hard time to understand. And also because machine learning, it is now so pervasive. So most operating systems and most computers are now able to use it. That it's a good solution for, in essence, allowing people to understand what is happening in the network. And we believe that instead of using machine learning in a very generic way, using always the same metrics, bytes, and packets, it is very important to give and to feed the machine learning algorithm with some metrics that are domain specific, because it is very important to give them information that allows machine learning to understand more of the traffic, not starting from simple facts such as byte and packet, just to repeat myself again, but to give more information. So the packet inspection, for instance, is a good way of doing that. And so it's important that our tools that are basically probes allow to generate what in machine learning is called feature at a very high level, so that they are very specific to this field. We believe that this technology is the future. So we see that more and more this technology is deployed. But at the same time, we believe that it is very important to work more on the future. So it means that we need to produce with our tools some flow information, so complement flows with metadata that allows machine learning to be very effective. So this is why we have decided to push a lot on the packet inspection, because we believe that extracting as much information as possible from the flows is key to allow machine learning tools to operate properly. If we see what is happening today and what is available today on the market, this is an example of an IDS. We also see that nothing changed since 1998, or let's say in 20 years, nothing has really improved. If you see these rules, these are very modern rules. They are from last year for detection of sunburst. So you see that in red, I have highlighted the basic ideas that are still here today. So in essence, you have to specify the ports, you have to specify the IP address, and eventually you will put any, because modern malware, modern threats are using ports and IPs that are constantly changing. And as you can see here in the content is still represented in binary. So instead of writing, as I've put here at the end of at the bottom of the slide, very simple filters such as protocol TLS and the SNI, so in essence the host name that is part of the certificate, the TLS handshake digitalcollege.org, they are searching bytes at a certain location inside the packet. And this is still the same story we have seen 20 years ago with IDSs, with Snort. Okay, this is something that we would like to replace with something more modern. So, and this is the idea that we had in mind while developing our stuff. We see also that traffic is more and more encrypted, so that we have to pay a lot of attention to the encrypted traffic, and also that encryption is also appearing in protocols that for a long time have been unencrypted. So, for instance, you see the DNS traffic is slowly moving to HTTPS. So an example is DNS over HTTPS. And the speed at the edge is also increasing. So you have more data to analyze, data that is more complicated to understand because of the encryption. And also data that is somehow different from what we have seen in the past, because IoT devices, for instance, are deployed in network segments that have some sort of privilege, because they need to talk with probably the key host. And so we require also some sort of supervision, because those devices are not installed in a data center. So those devices can really create the big troubles if there is a breach, or if they are replaced with other type of devices simply because of their position in the network. So basically what we wanted to do, and what I want to explain you today, is our approach. When I said machine learning is probably good for the future, we still have to take into account that most of our people of our community are people that have a network that is not huge, or that because of the open source heritage are using open source tools. They don't want to, or they don't have the possibility of buying costly hardware devices that are able to run the software, especially if you need GPUs or tons of RAM. So therefore, what I'm going to present you today is something passive. So we don't want to be active, at least in the first part. So I'll see the ongoing development are also trying to cover this the second part, so block traffic, and it has to be scalable. So the idea is that it has to run on a Raspberry Pi or on a small device. And it has to be able to understand what is happening, how the traffic is changing over time. This is a very important point. And everything is based on a library that we started to develop almost 10 years ago, that is called NDPI. That is a deep packet inspection library. And the goal of this library initially was to understand the traffic, was to try to see what was happening in the network traffic, simply trying to understand the application protocol. But over time, we have decided that it was not enough. So we said that it was very important for us to add also additional metadata. So for instance, here today we are talking about cybersecurity, and this is a good example. So we try to complement application detection and metadata extraction with the interpretation of the traffic. And in NDPI, initially, the goal was to understand, the layer 4 protocol, layer 7 protocol. And since that, we said we need to also interpret the traffic if it's good or bad, because people maybe use social networks every day, but if they have to list all the protocols used by social networks, it's probably something that is complicated to do. So therefore, we started to classify protocol. This was the initial part. And then we have added extension for cybersecurity. In addition to basic detection and decryption of, for instance, the initial handshake of communication and extraction of metadata. So, for instance, the certificate, name, the peers, the host that we are accessing, this type of information. We have decided to start to identify risks, if any, in network communication. So, because of that, NDPI is able to label traffic with something called flow risk. That is, in essence, an indicator of of risk, and we implemented many of them. So this is the list of the risks that we currently support. There are over 30 risks, and the list is constantly growing. If you see the last column on the right is what we have implemented basically in the last month. So it's a vibrant project, open source. NDPI has many other tools that we develop. And I put the color here to emphasize the nature of the risk. So if you see in black, we see something that applies only to clear text traffic, blue to both encrypted and plain text, and red only to encrypted traffic. And as you can see, we are still trying to implement with this concept those checks that, for instance, with the IDSs will be implemented using rules. And the idea here is that the library should be able to understand the complexity of the protocol and to report that to applications that are using NDPI this type of information. And of course, not all the problems are alike, because there are some problems that are more important than others. So therefore, we try to characterize each individual risk with a numerical value that give us an idea of the problem. So for instance, if you transfer here a binary application, this is not that nice, okay? Or, instead, if you have some invalid characters detected in payload that is supposed to be in clear text, so this is probably less important than this type of alerts. So for these reasons, we have created something called SCORE that I'm now going to explain you. But before moving to that, I want to show you a quick demo of the library. So in essence, this library is able to understand the traffic to produce a lot of metadata, as you can see, entropy information, for instance, ratio, protocol itself, and generate those risks. Okay, so for instance, this is a self-signed certificate, and it is using an obsolete TLS version. In the second example, this is an example from TrickBot traffic, that is a malware. You see that the application is moving a binary application. That is probably an indication that there is something that it is worth to be analyzed in detail. And because we are open source, we have said that we need to propagate our ideas and our tools also to other tools, because many people are using, for instance, Wireshark, we believe, for doing traffic analysis. So we would like also not to keep this type of information, for instance, the risk itself, limited to NDPI, but also to other applications other than those that we develop. So for instance, if you want, you can do this in Wireshark. So Wireshark, thanks to our library, is able to understand the application protocol, in this case TLS and EDESC, and also, as you can see here at the bottom, the risk that we have identified with the library. As I said, the risk have been used to create something that we have called SCORE. So that is a numerical value and also an indication. So here you see in this column, you see the severity of the problem itself, because there are some problems that are more severe than others, and there are some problems that are also not equally balanced between the client and the server. So for instance, if you send a traffic, as you can see, that contains non-printable character in a communication that is supposed to be in clear text, you see that this problem is has a high severity. Okay, there are other type of risk. So, for instance, cross-site scripting attacks, SQL injection, so on, that are severe, so even more important. Others are less important. And to each risk, we associate a numerical value. So in this column, as you can see, this is the value that we associate. And we also try to divide the problem from client to server. So if, let's say, for instance, cross-site scripting attack, so if a client is issuing an HTTP request that is trying to attack a server, so we say that most of the problem is on the client side and very little on the server side. The server side for us is important because even though the guilty actor is the client, we can also start labeling the server because the server is being attacked. So it is important also to report this type of information and not just limit ourselves to the client that is performing a certain action. And if you have multiple risks identified for a single communication, you will see that at the end, the total risk that we see for a flow is the sum of the individual risks. Okay, so in this case, we see 3 problems, one of value 10, 150, 110. So at the end, actually, there is an error here in this slide. So at the end, the total value here should be 70. Okay, so and this is to label the flow. In this case, we are able to identify and to give a severity to a communication. And when this communication it is now reported to the monitoring application, in our case to the probe or to the collector, we need to propagate this information to the actors. So, for instance, we need to propagate this information to the network interface where we have observed this value. And we also need to propagate this information to the host that is performing, a certain action. So, to the client or to the server, to the network, because this host belongs to a network, and of course the customer, because if you are grouping host according to a customer, to a user, or even a location, so you need to account this information not just for this host, but also to account it for a group of hosts, or for an autonomous system or a country. So in essence, you need to identify your source of trouble and to make sure that you have a way to understand who is creating the problem. So in order to do that, we have created something called checks. Okay, so as you can see here, this is a screenshot from ntop. So we have various type of checks. So one is, for instance, for the interface, one for the SNMP device, another for flow, and so on. Because the flows are basically the simplest building block you can imagine for creating, let's say, a system that is able to understand, threats, how they move in a network and where they are located. But we need to also consolidate this data according, like I said, for instance, to host or to interfaces or to other type of entities. And the flow, the single flow, is unable to give you an idea of the problem. For instance, if you see that somebody is trying to connect to a server, trying to guess the password, you will see several connections from one host or a certain protocol to a certain host. Okay, so for instance, somebody is trying to connect over FTP and trying to guess the password. So you will see that this type of activities cannot be detected at the flow level, but can be detected at host level or at the network level. So this is why we need to consolidate this information according to other type of metrics. So in essence, the flow is the basic building block. And thanks to the flow, we propagate this information to the monitoring interface, just to tell you, okay, on this interface you have troubles, that on this interface you don't. Also to the client, to the server host, and of course to the network and to the autonomous system. So in essence, we need to understand not just the individual problem, but also where the problem is located and how the problem moves in our network. But of course, this type of solutions don't work, okay, if there are problems that are not problems. So in essence, we need to discard false positives. Let's make an example. Suppose that you have a device, a very old device that is using an old version of TLS. Okay, so if we use our approach, you will see that this device is generating a lot of alerts, or simply because it is running an old version of TLS. But unfortunately, we cannot upgrade this device, but we have isolated the device in a way so that the device per se is protected, even though the device is still generating this type of alerts because of TLS. So this means that we need to apply something we have called exception, saying, okay, even though what we are seeing is not nice, we believe that this is not a problem for the reason I just told you. And for this reason, we need to create an exception. So we need to tell the system that, okay, don't generate this alert for this resource simply because we have decided that this is the best we can do to protect the resource. So don't consider that important. This because it's not possible to really say a device or a host that is not generating any flow with risk is good, or a host that's generating many of them with risk is bad. This unless we are able to understand and we are able to put exception, so we are able, in essence, to remove the noise from our network monitoring system. And this is because a system that is based on the score has to be reliable. So it means that it cannot report you information that are not that relevant, or at least that are correct, okay, like I said in the previous example of the TLS, but that don't apply to a certain network simply because this is something that we believe it is normal, quoted, because of the nature of the device. So if you want to add an exception, this is an example of ntop ng. You can see, for instance, this is an alert that is generated. So here there are some icons that I reported here underneath. So there is a bell here, a yellow bell, that allows you to disable this particular check for this particular host. So in essence, you are able to disable certain checks for specific, also for specific risk. So for instance, a monitoring system that from time to time is doing a network scan to know who's up and who's down, it is not supposed to generate any alert. And because of that, so with this solution, we are able to silence those type of alerts, and therefore we are able to make sure that our system is in good shape, because the system does not produce any alert that are not important or not relevant. So using the score that is generated from flows with the flow risk, or from the checks that are doing other type of checks higher than the flow level, so for at host level, we can consolidate this value at various levels. For instance, at host level. So in this picture, I have reported our host, and next to the host you will see the score. Okay, the score is accounted as the total number of the scores for flows active for this host. So it means that the first host here on the first line has several flows, okay, and those active, and those flows have a total amount of score of 11,100,000. As you can see, this is a very large value. So we can use this information to do actions, because we believe that this host, unless there are some exceptions that we forgot to silence, is doing something bad. At least we need to understand if it's the client score, so when the host is performing an action, or the server score, when the host is receiving a request coming from other hosts. But in essence, this is a way to spot hosts that are special. And in particular, if you go and visualize this information in ntop ng, you will see that it is very simple by looking at the score and dividing in client and server score to see who is the victim, who is the attacker. This is because we are able to depict this on a 2D, this is a bubble chart, for instance, a chart, and you will see somebody at the far end. You see here is an attacker, here at the top is a victim. So it's something pretty simple to use, because we expect, at least for the flow score, to be located here next to the origin. So this is a simple way of doing this type of things. And using that, it's possible to raise an alert. So you can see that alerts are divided in basically 3 categories. And the past alerts, so this is a system that allows you to store alerts, that have been generated in the past, alerts that have been acknowledged, so something that is not nice but has to be, accepted. Okay, so we say we acknowledge this alert, so either we have solved the problem, or we say this problem is okay, is not a problem in essence, so we are going to ignore it. And we see the alerts that are engaged. Because for flows, for instance, when you say a host is contacting, like in this example, suspicious DGA domain, this is one alert that doesn't have any state. Okay, but if you have a host that, for instance, that is contacting many hosts, that it looks like it is scanning the network, and that's then this triggers an alert, and as soon as the host stops doing that, then the alert the problem is solved, so the alert is gone. So this is what we say engaged. So engaged alerts are those that are still pending, that are still representing things that are not supposed to appear. And of course, with the alert, we report the context. So we report, for instance, this is an example for a DGA domain, the DGA domain that host is trying to access. So this is a DNS request. Okay, so it is very important to do that. And in case we have the concept of attacker and victims. So for instance, in case a client that is on a blacklist that is contacting a host that is offering a service, so we divide the client, we put the client into the, let's say, the attacker side. Okay, we put an icon, and the server on the victim side. Not all the flows have this thing, because for instance, when there are important things such as a blacklisted host or a blacklisted client that is talking with a remote host, we believe we can divide into attacker and victim. In other cases, it is not possible. So wherever it is possible, we label this traffic this way. And of course, using the score, our idea is that we are able to create a system that is able also to block traffic. Let's make an example. This is something we call dangerous host. It's a check that says if a certain host crosses this threshold of 1,000. 1,000 as score is very high for a minute, or at least a minute. Then we label this host as dangerous. Okay. As soon as the host stops doing that, then the host returns to normality. So this information is important for us because it allows us to understand, hosts that are misbehaving either continuously or for some time. And as you can see from this picture, if you want to see why, so if you want to say, okay, this host has a very high value, so for instance, in this case, 7,000 for the score, how did you account it? So in essence, here we see with this icon, it's possible to go down to flows and to understand how the host was labeled as such. But in addition to that, we have also added some features for behavior analysis. So in essence, we are not happy just to put a threshold and to say when we are above a certain threshold, there is a problem, when we are underneath, there is not a problem. But we also want to understand how the behavior of a host has changed over time, and in case the host is still doing, is still a good host because we are below a certain threshold. But if the nature of the traffic of this host has changed significantly from the past, then we want to be able to also to understand and to spot this type of issues, this type of cases that are not so important. As I said, we also need to interpret this in the big context. But it's also important to be able to offer an automatic system that is able to do that, because we see more and more that people are trying to solve this problem, adding a new screen to the system and trying to depict more information on the screen. But if you have a larger network, this is not going to be a solution, but because it's the system itself that has to report you this information instead of using a larger screen. So in order to do that, we said, okay, machine learning is a very interesting thing, but we don't want to use machine learning because, as I said, it's probably too heavy for many people. And because statistical methods have been out for a while, able to do this properly. So we said, let's use them to create a lightweighted model per metric. So we are able not to create a huge model, but a model per metric, per individual metric that uses very little memory in CPU, so that it is possible to have many of those models per host for each individual metric. And because you have many hosts, you will have many models. Okay, and for the record, we are using double exponential smoothing. That is an algorithm that is more than 50 years old, that allows us to implement upper and lower band. So in essence, this algorithm is learning how a certain signal is working. So for instance, imagine this is a number of flows that a host has active. It tries to speculate what is the maximum number of flows or what is the minimum number of flows that this host will have in the near future. And if the value is outside this prediction, outside of the high or low band, then we believe there is a problem, because this behavior has changed significantly. As you can see in this example here, when we see that we are outside of the boundaries, there is something to report. Okay, so this is yet another way of detecting issues. Like I said, the boundaries are important, but in addition to that, we want to make sure that it's also possible to understand the changes in behavior, okay, that we did not expect. So we have also a way through another check to detect this type of anomalies. And in essence, you will see this reported in charts. So if you see inside the charts that our tools are producing, you will see that the lower and the upper band, and you will see the value. And when the value, see here, the green is outside of the minimum and the maximum, there is an alert that is generated. In addition to that, we have to do lateral movement detection. So to understand when hosts are moving in a network in an unexpected way. So when they are doing activities or communication that we did not expect to see. In order to do that, we have created a model that is based on the observation of the traffic of some host. So we observe the network for some time. This is a preference in ntop NG. So we see who is contacting who. Okay, this is just for the local network, not for the internet. And done that, we see that we record this information, and as soon as a host is performing an activity that was not observed before, okay, or either you contact a host that was not contacted before, or you contact a host that you contacted before but with a new protocol, then we say, okay, this is something worth to be analyzed. And we do this through the learning period. So in essence, we have a period of time where our tools are silent, and they are learning what is happening in the network. And as soon as this period of time is over, we try to match new flows against the model. And in case there is something wrong happening, we generate an alert. Of course, for every communication, you can specify whether the communication is forbidden, not, or undecided. So it's very important to say, okay, this is what we expect, and this is what we don't want to see. So if we see this communication, then we can trigger an alert. And the same thing we are doing for beaconing. Beaconing are basically low volume communications that are periodic. So for instance, a host that is performing certain communication, every minute, okay, that can be something as nice as an SNMP walk of a switch, or a malware that is talking back to the master. So we do this beaconing detection through a very simple algorithm. So in essence, we create some quadruplets inside our software that keeps source, destination IP, destination port, and the protocol. This, of course, in addition to layer 7 protocol. And as soon as we see something that is repeating over time, okay, the system is able to understand the frequency. So the frequency doesn't have to be specified by the user, but is learned by the system while monitoring the network. We report this as a beaconing activity. So beaconing per se is not bad. So don't think it's something that we need to report with an alert. But if you see beaconing with the traffic that is unknown, either this is a good way of reconfiguring our DPI system for detecting this type of traffic, or if you see traffic that is unpleasant, for instance, IRC, then this means that there is something that we need definitely to analyze, because this is probably a good indication of a problem. And this is why we generate this as an informative alert. So it's still an alert, but it's very informative, so it doesn't trigger any action. But it is used by the network administrator to understand what is happening in the network. And of course, you can attach an action to every alert. Okay, these are examples. So for example, you can send a message to Discord, or you can send this alert to Elasticsearch. And this is something normal that I believe everybody expects. But what we have done here, we have done even a further step towards trying to enforce the policy, try to block things that are not nice, that we don't expect to see in a network. So in ntop, we have the concept of host pool, that is a logical group of hosts that for some reason they have to stay together. Okay, so basically this doesn't have to be limited by the IP address, by the VLAN, but if you decide that this host have to stay together because they are hosts used by children, so you can create a children host pool, okay, and put them in this place. So in addition to generate configurable messages for specific pools. So for instance, say send a Slack message for a certain pool or a log alert for other pool. Here we have created a special pool called jailed host pool. So in essence, when a host is misbehaving, ntop is moving this host to this pool automatically. So it's moving, for instance, from the children pool to the jailed host pool. Okay, this is because we want to identify and label hosts that for some reason the system believes that are doing something bad, and put them in a common place and execute actions on them. At the moment, what we can do is that is limited to one activity, so basically to block traffic. I will show this in a second. But the plan for the coming months is to be able to execute multiple actions. So for instance, to block this host in multiple ways. But in general, the concept here is that we want to label hosts that are special. We believe they have done something not pleasant, and to put them in a group, in a temporary group, because as soon as the host is back to normality, the host is moving from this pool to the original pool, and to execute actions that allows us to protect the network from this type of host. So for instance, in this example, if we see a host that for more than a minute has a score higher than 1000, then we label this host as dangerous, okay? And this can be combined with a special mode of mprobe called IPS mode. So in essence, mprobe has been designed as a passive application. So an application that is able to see what is happening in the network and to report this in flow format. But earlier this year, so we have added the ability of mprobe of monitoring, two interfaces. So in essence, to act as a bump in the wire. So this is called IPS mode. So in this mode, it's possible to send mprobe some rules, okay, that mprobe will implement in the traffic, and those rules can include, so for instance, things such as slow down this host, to other type of activities that include, for instance, activities such as block this host if something goes wrong. So the idea here is that we have added this IPS mode to the jailed host pool. So in case ntop when receives traffic in flow format from mprobe, understand that there is something wrong happening, can execute an action. What are the actions? ntop can, first of all, configure the policy for host based on the observation of the traffic. So for instance, in this case, here you can see that ntop has assigned to a certain group of hosts the protocols that have been used by this host. But in addition to that, if ntop sees that a host is misbehaving, this host is moved to the jailed host pool, and when the host is put in the jailed host pool, ntop sends an update to mprobe that says block the traffic of this host. And as soon as this host is back to normality, so basically it's removed from the jailed host pool, this host basically can now do communication again, because mprobe is allowing traffic to again for this host. And because many people are somehow interested to block application, but are scared also of doing that, We also offer the ability to run it in dry run mode. So it means that mprobe is passive, and ntop is reporting what ntop will do, okay, if it was in line, but that is not doing simply because we are working dry run. So people can start to understand, for instance, even with this facility, what are the features that need to be addressed, and what are the things that somehow need to be reconfigured in the network, probably for addressing this type of threats. So what I've described so far is what it is existing. Okay, so what you can use already today. Now, the idea of the second part of the talk is to give you an outlook of the development where we want to go, and these are, we believe, very important for us because we see interest in our community, and also because I would like to hear from you if you have ideas or feedback. So in essence, the goal for this year is to anticipate. Okay, so for many years we have seen that we need to defend our network, we need to manage our network, and so on. But the future for us is to anticipate, to make sure that we are able to block threats before they are real in our network. I will explain this in a second. So in essence, we want to be proactive. We want to make sure that the network is in good shape, but also that will be in good shape. So how can we anticipate a problem? So in essence, we need, first of all, to add additional checks that are more powerful than what we have today. And also, we need to make sure that in our system we are able to also to understand that if there is something wrong, this threat needs to be blocked immediately, as soon as possible, without waiting too long. And because our tools are designed for companies that are have a mid-size or small, we have some very large users, but many times we have users that are unable to spend a lot of money in expensive solutions. So we said we need to make sure that this solution is also a good solution for them, and they don't have many times system administrators that are administering the network. So they need a system that is able to, let's say, work automatically. Okay, so this is the idea. So in essence, we want to move from monitoring to enforcement. Okay, this is the plan. Now, we believe that cybersecurity will not be so important without the internet. So it means that if you have a machine that has a problem, okay, it is not nice, but if the machine is isolated from the network, then the problem doesn't spread. Okay. But unfortunately, this is not the case because everybody is networked, is in a network, is speaking with others. And in particular, inside a network, the east-west traffic communication are not easy to monitor because, we can monitor with NetFlow the traffic that entering or leaving a network. But many times when you are inside a local area network, the protocols that are available are, for instance, S-Flow that are sampled. So in essence, you don't see everything. You just see one packet out of 1,000, for instance. So it means that they are not designed for high visibility. So they are not able to do that. And also threats try to add themselves. So they want to show up. They are not volumetric attacks. Okay, a volumetric attack is bad. So if you think about a DDoS, but it is nice for a monitoring device because it's easy to detect it because you see it's huge. It's a lot of traffic. Here we see that many times those attacks start very slowly, okay, very low volume, and then they create the problem. Okay, so we said to ourselves, how can we address those requests? Okay, do we need more packets? So in essence, do we need to remove sample? Do we need more machine learning, or do we need more checks? Okay, these solutions are nice, but they add complexity. So we said, let's try to think in another way. So if you remember, in 2018 we have introduced an agent only for Linux that was called mprobe agent. mprobe agent was able to report information such as these two lines that I listed here about hosts that are doing certain network communication, and in addition to that, we also give extra information, report, for instance, the application process that is doing that. As I said, this was a Linux-only agent, so we said that we need, first of all, to support the Windows, okay, and also because some people were confused about this solution, because you see, you have mprobe, you have mprobe CentOS, you have mprobe agent, too many mprobes. So we said, let's now discontinue mprobe agent and put the features of mprobe agent inside mprobe so that mprobe itself can report this information. So because of that, we now have extended, and this is already available in the current dev version of mprobe, with other information that is basically reporting information about the process behind a certain communication. In order to do that, of course, you need to install mprobe on the device, on the edge device. But as I said, first of all, this is not a problem. Today, you see many agents, installed on machines. We see a huge market for solutions such as those cybersecurity agents. But also, we have decided to support Windows. So we're able to support both Windows and Linux. The original agent was only Linux. And as I said, for lateral movement, for monitoring a LAN, it is impractical today to mirror everything because, if you have a 24 port switch, for instance, the amount of traffic you have to monitor is huge. It's 48 gigabyte of traffic. This is gigabit of traffic. This is already a lot of traffic. So putting an agent on each machine is not too bad, okay? So you can monitor the traffic with this machine. In addition to that, you get a bonus because you can also have system visibility that is invisible to the network. So for instance, with the current mprobe, this is mprobe deployed on a Windows machine, you will see that this communication, so in essence a connection to Twitter, is performed by Chrome, okay? So we know the application that is performing a certain communication. This is very nice for both TCP and UDP. And this means that if you have a part of the network that has only flows, for instance, flows coming from a router, fine. If you have a part of the network where you also have, the agent running on your box, you can complement network information with process information. Or if you have devices that are invisible simply because you are unable to monitor the traffic through a port mirror, through a tap, because you have this on a LAN, installing the agent allows you to report this information. I forgot to say that this information is not just reported on the web GUI, but it is also stored on disk. So it means that in our plans, we want to be able to say, okay, give me all the traffic that Chrome on this host has produced. Or if you see a threat, you say, I want to know who has generated this problem. And you say application X, I want to see where the application X was deployed and what are the machines that are using application X. This is the idea, okay? These are ongoing developments. Some of it is already available, something else is coming. So the advantage is that we are able to see who is doing a certain action. We are able to see, who are the processes, or if we see a process that we don't expect. So in essence, we are able to enhance system visibility. But again, this is not enough from our point of view because it's still a monitoring tool that is not bad, but is not blocking anything. So in essence, we said, what if we move towards EDR? And what if we enhance and probe with extra features that allow you to block threats or to block activities that are not expected? So for instance, the first thing we said is this. We want to detect the changes, okay? Changes in configuration are important because whenever there is a change, either a network administrator has done some sort of reconfiguration or something has changed in an unexpected way. So we need to understand, for instance, who is doing what, okay? What is the process behind a certain network communication? And if there is a new process that we didn't see in the past that is doing traffic, or for instance, if there is a server, okay, that is listening to a certain port that we didn't see before. So how can we do that? In nprobe, we have added, in essence, this new feature trying to answer the original question, so block before the problem shows up. So in essence, if we see a new application that is listening on a port that was not used before, or if we see that on a well-known port, the existing application is now replaced by another application, is this normal? We don't know. I mean, this is not a task for the probe, but if the probe can report this information, if the probe can block this type of communication, that would be very nice. Or if we see, for instance, applications that are not part of any package that are doing traffic, is this normal? Or if we see applications running from an unexpected path, for /TLP, okay, that is very typical of malware that they try to save temporary data in this location and then start up. Is this normal? We believe it is not. So in essence, we have decided to enhance nprobe. So nprobe is still, the same nprobe as you know, but there is a new way of using it that allows you to block this type of traffic becoming an active probe. So in essence, the nprobe IPS I've shown you before is still based on the network concept. Here, we also have some sort of system visibility that can very well fit with the zero trust principle. Because in zero trust, you will see communication between host and ports. Here we see communication between processes. And this is possible because nprobe is listening to system events. So for instance, we know when a new port is in use, when a new application is started. And we try to leverage on Redis to store in Redis this information to have some sort of learning, as I've shown you before with the service map. I want to show you how it works. So in essence, you can start nprobe using Redis as a local cache in a way so that it learns how the traffic is generated, what are the applications generating traffic, what are the ports being used, and storing this information into Redis. And then after the learning period, nprobe is trying to enforce the traffic according to the past. Just make an example. nprobe, for instance, is storing this information inside the Redis. For instance, I see these are the whole users that are generating traffic, and you see for the user root what are the applications that have been started before. Okay, here we don't talk about IP addresses or ports. These are good for good information, minimum information for the collector, but nprobe on the system has to be able to enforce and to make sure that another application is not started because this application was not supposed to be started. So, in addition to that, so in addition to knowledge of existing traffic, we have also add another feature that is the packaging. So, for instance, unless you're developing applications, so you're a network or software developer, all the software that you deploy on a system has to be part of a package, okay? So if we see that there are applications that are generating traffic or receiving traffic that are not part of any package, this is probably a problem. So at the moment, this is a good indicator of compromise, we believe, because these are applications that are not supposed to run. And at the moment, as I said, these are ongoing developments. We support only Linux. So we support both Debian and RPM families for packaging. So basically the CentOS, Red Hat, and the Ubuntu Debian systems are all supported. On Windows, we don't have this facility. Actually, we have no clue how to implement it. We started to look at tools such as OS Query, but at the moment, this feature is Linux only. And it works this way. So in essence, when a flow is reported, you will see not just the process, in this case SSHD, but also the package to which this application belongs to. So you see the traffic, the context, and the package. And you can say to nprobe, block traffic for applications that are not packaged, okay? Because this is usually an indication of malware. In addition to that, we also want to look at the server side. So to the fact that there are some traffic flows that are invisible simply because there is an application that is listening on a new port that is waiting until somebody is connecting to it. Okay. So how can we see this information? Not with flows, because there is not a flow simply because there is no traffic, but we want to also make sure that it's possible for a network administrator to detect this type of changes, so to see that there is something new happening, and also to hide, to make sure this is not hidden in the background noise. So in essence, in nprobe, we have also added the ability of detecting those type of changes, see when there is a new port in use, when an existing port is used but by a new type of application, and also to report this information to a collector and to basically block this type of applications. So just to make an example, this is a typical example. So we see on this host, these are the IP addresses that this host has in use. Or also, it might be that the host is adding a new IP address with respect to the past. You will see here the process and the package name. In case there is no package, so in my case here I was developing nprobe, so it's normal not to be part of package. You can say that this is a problem that has to be blocked. And nprobe is doing that by the concept of flow verdict. So nprobe, as I said, is running in inline mode if you want. So the nprobe IPS is basically acting as a bump in the wire. So in case we see that there is traffic coming from an application that was not observed before, so there is a trace route in this case, this simple example, or an application that is not part of a package, okay, then we can block this traffic. This is simply through a configuration of nprobe. So this means that nprobe is not allowing communications that are unexpected. So it's the system administrator that has to make this possible. So in essence, we want to move from monitoring to enforcement and to add these two features all at the same time. And this is done in a simple way, simply changing the network device from which we are receiving traffic. So if we have traffic coming from an Ethernet interface, so this EMP5, okay, this is in monitoring mode. So if you're receiving traffic from a net filter, this is enforcement mode. So in essence, nprobe is enforcing the traffic and blocking, applications or ports that are not supposed to be open or that changes with respect to the past. So this is our plan. So for nprobe and ntop. At the moment, most of the features are available on Ubuntu 18 and 20 and on Windows. On Windows, I told you that the packaging part is not present. Everything else is there. We believe that by the end of the year, or probably more likely in January, we release these applications. And of course, I did mention that we support containers, so you can also see extra container information if you want. And this is the plan that we have in mind. So in essence, to create something that is simple, is active if you want, because you to decide if you just want to see what is happening or if you want to enforce it. It is available both on Linux and Windows. Windows, we believe it's important because many companies Windows is predominant, and many times Windows visibility is limited. And so we have to make plans for cybersecurity, and this is what we have in mind. So I want to thank you for listening, and I would like to know if you have questions, comments, or suggestions. It's your time to talk now.
Thank you very much. I don't know if you can hear me. That was really well detailed, and I really appreciate all the work you've taken to break it down the way you have. I have more understanding of ntop and nprobe than I ever did before, so I really just want to say thank you.
Thank you. So I see questions in the chat. I think most of them have been already replied by Alfredo. But if you have questions, or if you want to give a feedback, please feel free to open your microphone. And this presentation is recorded and will be shared on the ntop blog and on YouTube. So in case you want to see it, also the slides.
I have a quick question.
Please.
The enforcement part. It's how is this possible? Because most of our traffic is captured through another port. It's usually passive. How do you enforce, for example, if you want to block a host? Because usually our firewalls are, before ntop. So ntop is maybe the second device listening to all this traffic. Mm-hmm.
Okay, so at the moment, we have two ways of doing that. This is just nprobe, okay? Nprobe, it's basically a bump in the wire if you want. But inside ntop, let me go back to previous slides. Inside ntop, at the moment we are able to enforce to block host only using nprobe IPS. But the plan is the following: to add SNMP support. This is already part of ntop, was part of ntop version 4, but we need to update the check for the version 5. So in essence, as soon as a local host that is attached to a port of a switch that we are monitoring through SNMP is misbehaving, we can basically drop the traffic of this host, changing the status of the port. So basically, we change the operational administrative state of the port so that the host is unable to communicate. So this is another option. We also have other type of checks. So let me see if I can show you. So for example, here we support a fail to ban, for instance. So fail to ban is a popular tool that allows you to block a certain host. This is Linux only technology. We also have a tool that is able to do DDoS mitigation, it's called Scrub, but one of the plans is to integrate with commercial solutions. So for instance, if you have a Fortinet firewall, we would like also to support it, or if you have other type of firewalling system, commercial firewalling system. So in the future, and this is one of the things that we want to do, at the end of this year, early next year, is to enrich the list of actions you can perform, because blocking a host is something that we should not perform ourselves, but if in the network you have something that is already in place. But please, I would like you to make sure that I'm clear on this. So when we have mprobe, okay, when we see that here there is traffic that is generated by an application that is unexpected, or is generated by an application like here that is not packaged. So in case we want to block this traffic, then the agent itself, so mprobe itself running on the machine, is the way to go, because here we are able to selectively block this traffic and allow other traffic to flow. Okay, of course you're free to block the whole system, but this is not our goal. So the goal is to make sure that we implement a sort of app armor, or SE Linux if you want, for the network. So make sure that the host is still working, but this is not this traffic is not moving. So in this case, then is the probe itself on the machine that will block the traffic. In the other case, we can leverage on the environment, on the existing firewall, for instance, for doing the block. I don't know if I answer the question.
Yes, thank you. That was very nice. Appreciate it. Yeah, we can focus on what you're saying is use mprobe to deal with specific things like that. Okay,
thank you. Other questions?
I have another question. Sorry to bug you guys. I just wanted to ask you, because I noticed this is mostly, saying, okay, something is bad, something is good. Yes. So I was wondering if there is any idea basically to do a quality of service, like, maybe let's say a torrent is a bad thing, but maybe it should be still allowed, but maybe go into, let's say, a class 8 public service or something like that.
Yeah, I mean, this
like buffer it and just not give it enough of, bandwidth limitations and things like that. So.
Yes, this is something that we do. We do this with mprobe. As you can see here, it's possible to configure the protocols that are to pass or not. Here you see the pass policy. Now, mprobe can do that. Okay, so in essence, actually, it's a very simple exercise, because when we say pass or drop, in essence, we put a marker on this traffic. Okay, this can work on Linux or on BSD. So OPNsense or pfSense is supported. So in essence, block or non-block is simple. What you want to do is probably to shape, so to reduce the bandwidth. This is possible on Linux, because is this what you want, Josip?
Yes, exactly that. That was the question, basically.
Yes. So if you send me a mail, I can send an example. So in essence, you have to configure net filter. Okay, we have a few examples. Actually, we have some ISPs that are using mprobe for that. So in essence, they do this. You have to configure net filter, okay, and in net filter you specify the quality of the traffic that you associate with a certain marker. Okay, in this case, pass or drop have 100% bandwidth or zero bandwidth. Okay, so what you want to do is something in the middle. So we can definitely do that. Okay, it's a bit more complicated, and you want to go too deep into this presentation, because I'm already using 1 hour. But it is possible. So in essence, you specify the marker for that. So there is a configuration file that with ntop and G here you can edit graphically, or that you can have. It's a JSON file. So you pass to mprobe in IPS mode. So when mprobe sees that, it says, for instance, block Facebook, okay, or for this group of hosts, allow Facebook, but at this bandwidth, this type of things. I hope this is what you're looking for.
Yeah, that's perfect. And sorry, if there's time, I would like to ask one more simple question. So it comes to basically to the bump in the wire, right? Because most of the ISPs, if you think about it, if you would put a bump in the wire device, it would be somewhere, let's say, on the transit network, going out, going in, doesn't matter. So typically you would want to protect yourself. So I was just wondering if you support any Ethernet cards that would basically say, okay, let's say the ntop host or the process dies, that basically the traffic would be switched normally in between.
Yes. We support some of the cards, in particular those from Silicon. So there is a bypass switch. I believe this is what you're talking about, right?
Yep. Yeah, that's one.
Yes, they are supported. Actually, one of the things that we'll discuss early December. In December, we want to run a short conference online, so a couple of webinars to explain you also other things. We'll be talking about Mellanox. So we have added Mellanox support in our software, and this is a great card because it allows you to specify filtering rules in hardware. So this is definitely a good target for the future. It does not support this feature, this bypass switch, but allows you to offload a lot to the card in case, in particular, you have a strong sender of traffic that you want to block. We will talk about that in December.
Oh, okay, that's perfect. I assume probably you support Xilinx as well, then, in that case. You do a lot of hardware offloading.
Which Xilinx? What is the company name?
Xilinx. Xilinx is the company name. I think I have to look actually. The US company name that does the firmware for them. I think it's on supported list for you.
Okay, send it to me because we support some of the cards that are based on Xilinx, for instance, Accolade, but I am not aware of.
Yeah, that's the one. Accolade.
Okay. Yes, we do. Yeah, but the difference between Accolade and Mellanox is, for instance, the number of rules. And I mean, the plan is that what you've seen today is just the beginning of something that we want to implement. Okay, so at the moment we are software only because, as I said, many of our users, are mid-sized companies, and installing an agent gives them visibility, also the ability of blocking that. But we definitely want to do that in the future. So we want to be high speed. Just to give an idea, mprobe running in IPS mode. So this one I showed you before, basically this one, okay, is able to run at 10 gigabit. So we have ISPs that are doing 10 gigabit. So with two cards that are able to in essence to block or to shape traffic. Okay, this is pretty normal. In particular for wireless ISPs that have several problems with streaming videos. Okay, at some point, at a certain time of the day, especially in the evening, they are creating so much traffic that they want to block. Yeah, U50, yeah. We will support the 55, that is a small form factor card. Yes.
Oh, this is perfect. Thank you very much, and it's an amazing product.
Thank you, Joseph. Other questions? I see some messages on the chat.
Yeah, Daniel was asking if you support encrypted traffic analytics in information elements in a probe from Cisco Catalyst.
No, so in essence, the catalyst that is exporting data, I believe.
Yes.
No, this is something that we have not done before. I mean, if you can contact us and explain this in detail, if possible, we can do that. We just read of it, but we have never encountered, one of those devices. Please send us a mail and we'll talk about that. Maurizio is asking, actually probe is exporting flow risk name and score, but not the object related to. So for instance, the application, the binary application. Okay, let me see if I have one of these risks. No. Yeah, so when it makes sense, like here, we specify the domain name. In case of the binary application, you're right, we don't export the file name, but we export the URL. So let me show you this before. No. TrickBot, yes. So in this case, for instance, TrickBot is doing, this is an infection, okay? So it's calling this solar.php, okay, this one here, and we are, exchanging a binary. So in this case, there is no application name. So we report this with the URL because sometimes you see the file name that is being exchanged, but many of the times you cannot. We think about that, but I want to make sure that we are on the same page here. So this is for clear text traffic. Okay, so again, this is from last year. It's TrickBot. It's a modern malware, but at the same time, we are able to say this is a binary application because this traffic is unencrypted. This is still HTTP, as you can see. Okay, so we believe that as long as those malware are around, okay, it makes sense to invest time on this type of visibility. But in general, we have seen that malwares are also moving to encryption. So soon this type of detections will not be possible. But we'll think about that, how to report that information. Any other questions?
Sorry, one quick question. Do you still support NBox, or is NBox still available? Because it was easier to use it to install ntop ng.
Yes. The NBox is still around, but one of the plans that we have in mind is to create a simplified version of the NBox, let's call it this way, that allows you to install nprobe and ntop ng and basically the basic drivers, and to leave NBox for those who need advanced features such as tuning low-level drivers, because we see that many people are creating small boxes, putting our tools on it, and they need a GUI, a simple GUI. So yes, we support the NBox, but next year we want to create a simplified NBox GUI that is probably integrated in ntop ng, that allows you to do all this in a simple way for small, for users that don't need very complicated things.
What license is necessary for this development?
What did you? I didn't hear the beginning of the question. Say it again, Alberto.
What license is necessary for this development?
You mean for the NBox you're talking about? What are the developments that you have in mind? nprobe? I mean, nprobe is available for as a ntop ng for Windows and Linux. I don't know if this is what you asked me. No more questions? Okay, so if there are no more questions...
Sorry, one quick question. Are there any best hardware that you would recommend, anything?
For what? For
running and installing ntop.
I mean, for ntop ng, it depends how many hosts and traffic you have. So we have used Intel for a very long time, okay? But recently we have started to give a look at AMDs. So if you want to have a reasonably cheap server, okay, that has many cores and is very powerful, I suggest you to consider Intel, but also to have a look at AMD EPYC, okay, because they are price effective, okay, especially the entry level EPYC has 16 core hyperthreads with 32. So it's very good, in particular if you have to deploy many instances or if you have many interfaces to be monitored. But in general, for 1 gigabit, I think that any host is good. For 10 gigabit or more, I would suggest you to give a look at this new EPYC from AMD, because it's very fast and as I said, price effective. I see that there is a link here in the chat. Okay, this is also a nice box. Yeah, for low end, this is a nice box. This mini PC, yes. Yeah, with the Intel Celeron J, it's a good solution. There are many of them available, from no brands to big brands such as Supermicro. But yeah, with $200 price, $200-$300 price range is it's a good system. They are very fast. They're very fast for one ntop detectors.
I just want to say thank you very much. I really appreciate this presentation.
Thank you. My pleasure to have you here today. Some more questions? Okay, guys. So I want to thank you. We'll put this presentation on the internet, also the video. I thank you for being here. And as I said, we'll organize something in December. So you will hear from us pretty soon. Thank you very much.
Great job, Luca. Thank you.
Thank you.
Great work.